Good morning. I'm going to walk through one problem here on exponential. I believe it's decay. Let's see here. Well, a couple. Let's go through a couple of these. So we got this one. This was a question from the homework that was sent to me, talking about. It's a half-life question, but it's not really like one of the problems we've been doing. It says the half-life of a radioactive element, unobtainium, which is fake, I think. I don't know. Maybe it's real. You guys tell me. It's 5 seconds. So that means it takes 5 seconds for any amount of this to reduce by a half. So if you have 80 grams of unobtainium that are originally present, how many grams are present after 5 seconds? That would be 40, right? Which is half of 80. After 10 seconds, that's 2 half-lives, right? We would have half of this, which is 20. After 15 seconds, that's another half-life, of which there's 20 remaining, so now there's 10. So we see what we're doing is we're constantly dividing this by a half. You could look at it from a basic exponential growth model saying, you start with 80, but you're taking half for every half-life cycle. Like if we call this a half-life cycle, you could write just a basic exponential model for this and say, after 1 half-life, you're taking half of 80. After 2 half-lives, you're taking half of 80, so on and so forth. So that's something that we didn't really talk about that much, but understanding the concept of half-life as every time 5 seconds ticks off the clock, half of this goes away. Okay, hopefully that makes sense in terms of questions about half-life here.